Hello guys, so we are going to continue the discussion with respect to derivatives. In this video, we are going to discuss about tangent of polynomials. Now, let's say that I have a specific curve, okay? I have a function and this function looks something like this, okay? Let's consider the curve looks something like this, okay? I'm just drawing some curves over here. And let's say this entire function is basically denoted by f of x is equal to x cube minus 6x square plus plus x, okay, plus x, and this can be minus 7, okay. So let's consider that this is what my function is basically denoted as. So this basically becomes my x-axis and this becomes my y-axis. Now, what is our aim? Okay, what is our aim over here is that let's consider that I will consider one data point over here, and then we will try to represent. See, at the end of the day, whenever we really need to find out the slope with respect to that point, we need to probably create a tangent line, right? And this tangent line will basically, this point will basically talk about the slope of this, right? And for this tangent line, we'll go ahead and calculate the slope itself, right? Now, can we use some kind of equations and represent this straight line, right? Can we represent this line using some equations? And I'll tell you why this will be important. Using some equations, using some representation at least, okay? Let's say that this data point over here for the x value is 1. Let's consider that this is right now 1, right? Let us do one thing, okay? If I go ahead and calculate what will be my f of x if I go with respect to 1, what will be this value, okay? So here I will replace x with 1. So this will be 1 minus 6 plus 1 minus 7. So overall, if you do the summation, you can see 1 plus 1 is 2 and this is 13. Right over here, you'll be able to see that you're getting minus 7, minus 6, 30, minus 13, minus 13, minus 12, minus 11. So this, I'm just going to consider it as minus 11. Okay. So this is what is my ff1, right? With respect to my y coordinate, what is the value if my x is equal to 1, if I just replace in this equation. Now let us go ahead and calculate the derivative of f of x, right? So this is nothing but derivative of x with respect to x cube minus 6x square plus x minus 7. Okay. Now, if I go ahead and find out the derivative, it is quite simple. Till now, we have seen multiple examples. So this will be 2x square. This will be 12x plus 1 minus 0, right? This will be exactly 0. So here, this is what is my derivative. It looks like 12x plus 1. And this is what is my f dash of x. Now, if I try to find out my f dash of x when x is equal to 1, that basically means I'll go ahead and multiply 1 over here. This will be 12 and this will be 1. So overall, you'll be able to see this will be 12 minus 12 plus 1, right? So this is nothing but minus 9. So here you are able to get f dash of x as minus 1. Please remember this terms, okay? And this is what? This is my slope, right? Now let's consider this tangent line, this tangent line that you have, right? This tangent line. How do we equate this? This tangent line can be given by the equation y is equal to mx plus c, right? And what is my m value? M value, you know, it is nothing but minus 9, right? So m is nothing but, so here I will go ahead and write minus 9 x plus, I still don't know what exactly c, right? I still don't know what exactly c, right? Over here, the c value still we don't know, and we usually call c as intercept, but we know the y value. The y value with respect to the y value that we calculate, right? See, this is my y value. My f of 1 is basically my y value, right? My f of 1, that is what is my y value. So here I will go ahead and represent minus 11, right? So minus 11 minus 9x, okay? And then here we will go ahead and write plus c. Now, you know, since we are calculating y for 1, then obviously this x will also be 1. So here I have minus 11, minus 9. So here only I can write, right? So for x is equal to 1, see over here. For x is equal to 1, so let me just go ahead and write. For x is equal to 1, you know what is my y? y is nothing but this one, right? This is nothing but it is equal to y itself, right? This is nothing but minus 11. So minus 11, then minus 9 into 1, it is nothing but minus 9 plus c. So here if I go ahead and calculate c, it is nothing but minus 11 plus 9. So this is what my c value is. And if I further calculate this, this is basically going to give me minus 2. So after you have calculated the value of c is equal to minus 2, so for this point, if I want to represent this entire tangent with some expression, I can go ahead and write something like this. Y is equal to, so let me just go ahead and write y is equal to mx plus c, right? You know what is my m value? My slope value is nothing but, we calculated it over here for that particular point. It is nothing but minus 9. Minus 9 x, and you know the c value, it is nothing but minus 2. Now here, this is my equation for that particular tangent line at that particular point, right? At the x value is equal to 1. Now this minus 9 is nothing but my slope. This is my slope, and c is equal to minus 2 is my intercept. What does intercept basically mean? Intercept basically means that this line that is probably meeting in the y-axis, right? It is basically meeting it over here at minus 2. That is what it indicates, okay? Now you may be thinking, Krish, why I am talking about all these things? Why I am probably going ahead and probably providing this particular equation? Understand, let's say that I have a data set, and the data set is something like something called as IQ data set, right? Let's say a student is basically having some IQ and he is scoring some marks, okay? If the IQ is 100, let's say the person scored around 98 marks. If it is 90, 97 marks, like this, we are just putting some details. Let's say it is 90 marks, okay? Now, when we try to create a model, okay, our model should be able to predict. Whenever we give a new IQ, it should be able to predict what should be the score of the student. Now for this, you know, if I just go ahead and plot all these data points, the data points will look like this, right? This will basically be my IQ, this will be my score, right? And this obviously follows some kind of curve, right? But just to solve this problem with a simple linear regression, what we will do is that we'll try to just go ahead and create a best fit line, right? Now, with the help of this specific best fit line, you know, what we are basically going to do is that, and this best fit line is obviously represented by y is equal to mx plus c. Now, what we will do for this entire solution, we will try to find out, and since the slope is same for all the data points, if you really want to solve this problem with a linear regression, this is basically called as a linear regression. I will also be providing about this algorithm in this tutorials itself as we go ahead, okay? So we are trying to solve this in the form of, with the help of linear regression. That basically means we'll go ahead and find out the best fit line, and we'll try to find out the right slope and right intercept, which will satisfy this line, such that for any data point that you try to predict, we should be able to get the answer. We should be able to get the answer. We should be able to predict the point. This is with respect to linear regression. Now, there are also some algorithms which, if I have this kind of data points, we will try to probably create a curve. This curve will try to satisfy this values, right? With respect to any value, we will be able to do the prediction. Now, for this curve, you know, the slope will be different. So here also we have to probably go ahead and find out different tangent. Here also we have to probably go ahead and find out different tangent, right? So for this, we will definitely be requiring this kind of derivative concepts. As we go ahead, there will also be understanding about something called as chain rule and all, right? Chain rule. And trust me, when you see the first algorithm that is called a simple linear regression, you'll be seeing that we will be using this kind of derivative probably to do something called as optimization. It's okay if you don't know right now, because I will cover this topic also, optimization and how derivative is basically used. Here, my main aim is just to make you understand what exactly is derivative, how things are basically working. But once you see your first machine learning algorithm, you should definitely be able to understand. And in this course, I'm going to put that particular video also. Okay.